Pre-algebra, Mr. Lawrence here, and here's your next flip lesson. And after today's lesson, hopefully you'll be able to say, I can convert linear equations to slope-intercept form and then graph. All right, so remember that the other day we were solving to get y alone. Remember, Sopka was demonstrating that she was circling the y, okay, because that's what we want to get alone. Once we have y alone, we're in what we called slope-intercept form. So I'm going to ask myself, what is keeping the y from being alone? Well, I've got this 3 here. I'm going to take 3 away from the left-hand side. Then I'm going to have to take 3 away from the right-hand side. Now, I don't do it twice. I don't do it here and then again here. If I did it twice, I'd be taking 6 away from the right-hand side. And I only want to take 3 away. And notice I wrote the -3 under the -2. Why? Because they're like terms, right? I'm matching up my like terms. So my equation turns out to be y, those cancel, equals 1/3 didn't get used, 1/3 x comes down, -2 minus 3 is -5. Now y is alone, I'm in slope-intercept form, and I can say, well, b is going to be 0, -5, and then my slope, m, is going to be 1/3. Remember, the numerator is the rise number, how much I rise or run, and the denominator is the run number. So I'm going to go ahead and graph 0, -5. So 0, 1, 2, 3, 4, 5. And then from there, I'm going to rise 1, run 1, 2, 3. Rise 1, 1, 2, 3. Right? And then I'm ready to draw my line. So let me see, I think that's pretty good. Something just like that. And of course, I'm going to put an arrowhead on the end of that line that doesn't have it. And there you go. All right, let's look at a couple more examples here. Y is definitely not alone. I'm going to circle the Y. Looks like I have a -3, but that -3 is attached by multiplication, right? So I'm going to get rid of it by dividing by -3. Now, I have to divide in all 3 places. It's kind of strange, but it's actually a form of distributing. Oh, excuse me. Still can't shake this allergy or whatever it is. So when I do this, those -3's cancel. I'm left with y. Now I like this fraction, this 2 over -3, so I'm going to write as 2 over -3. Bring the x along for the ride. And the -12 divided by -3 is a +4. Okay, so I'm going to find my y-intercept. Now that y is alone, it's going to be 0, 4. And my slope is going to be 2 over -3. Remember, the numerator is the rise number, denominator is the run number. I plot 0, 4, 1, 2, 3, 4. Okay, and then I rise 2, and I go left 1, 2, 3. I rise 2, and I go left 1, 2, 3. Okay, remember, I only have to do 2 points. I do a couple extra just to make sure it works out pretty. I don't know if you were paying attention as to what I just did there, but I actually used another form of the slope. Let me put my arrowhead on here and I'll show you. I won't know if you know this, but 2 over -3 is the same as -2 over 3. If you punch them in a calculator, both of them will give you a display something like this, -0.6, and that 6 will go on forever. Maybe it'll round when it gets near the end. Both of them will end up being this decimal. Okay, -0.6 repeating. So what I did was I went down 2, that would be -2, right? And then I went +3. So I just changed both signs. Remember that when we were doing problems in the last video and we had like a -1/2, we said that negative had to either go to the numerator or it could have gone to the denominator, but not both. So all I did was switch where the sign was and I end up with the same line. Okay, 2 more examples. These get a little bit more involved because There's a couple steps to them. These are just like the problems we did on over the weekend. Circling the y. Okay, I got to get rid of the 5x first. It's attached by addition because it's positive. So I'm going to subtract 5x. So, going to do that. Those are going to cancel. 3y. These are not like terms, so I'm just going to write down negative 5x minus 18. And remember, Mrs. Sopko mentioned that Mr. Lawrence's preference is to write the x term first. It's for problems like this when I go to graph that I decide to do that. You'll see in a minute. Okay, so still have my y circled. It's still not alone, so I'm going to divide by 3. But when I divide or multiply both sides, I have to do it to all the terms. And my left-hand side will become y. My right-hand side will become negative 5/3 x. And I'll have a minus 6. 18 divided by 3 is 6. So my y-intercept is 0, negative 6. My slope is negative 5/3. Okay, so let me see here. 1, 2, 3, 4. Oh, I lost my origin for some reason. 1, 2, 3, 4, 5, 6. And then my slope is negative 5/3. 1, 2, 3, 4. I guess I could estimate 5 and go 1, 2, 3. But a better way might be to do this. Go 5/3. Just move the negative to the denominator. So I could go up 1, 2, 3, 4, 5, back 1, 2, 3. And then I could do it again. 1, 2, 3, 4, 5, back 1, 2, 3. Right? And so now I can go ahead and graph, get my line going. 1, 2, 3, 4, 5, 1, 2, 3. Okay. And, you know, that's a pretty good estimation. I hit that point that went off the graph, but sometimes it's hard to be accurate. So that trick of moving that negative to the denominator or from the denominator to the numerator can be very useful. Okay, one last example here. And again, it's a two-step equation. I got to get that y alone. I've got a negative 6 there, negative 6x, so I'm going to add 6x to both sides. They're not like terms on the right-hand side, so I won't combine them. My left-hand side simplifies to 2y. Circle in that y. Okay. And I'm going to divide by 2, divide by 2, and divide by 2. My new equation becomes y equals 6/2 is 3, but I like my slope to be a fraction, so I'm going to write it as 3/1. 2 divided by 2 is 1. So my y-intercept is 0, 1. And then my slope is going to be 3/1. So 1, 2, 3, 1. 1, 2, 3, 1. And now I can go ahead and 1, 2, 3, draw my line. And there we go. All right, that's it for your lesson for tonight. Have a good night, everybody.